In our dreams, we break free from the shackles of everyday life. We are free, free to dare any thought, free to traverse the entire universe in our minds. And today, in this dream world, we embark on a journey through space and time. We have already reflected on gravity, that invisible force that holds us all down, embraces the stars, and keeps planets in their orbits. We have learned about the Casimir effect, a barely perceptible force born from the vacuum itself, a quiet piece of evidence that the supposed nothingness is indeed full of secrets. Now, let's imagine weaving both of these ideas together. Could this help us understand the universe a little better? Even though the Casimir effect is far too weak to explain the nature of gravity, it could still point us in the right direction. A fragile path leading to understanding. So, perhaps this effect has a big brother, a powerful relative whose existence we do not comprehend. Not yet. Some mysteries elude us not because they are unsolvable, but because we view them from the wrong perspective. And sometimes a gentle shift in our perspective is enough to bathe the seemingly inexplicable in a new, quiet clarity. Almost as if the universe had simply been waiting for us to ask the right question. If we apply this altered perspective to gravity, we encounter a model in which gravity does not originate from within things themselves, but acts as a ubiquitous external force on every system. In this picture, gravity possesses a maximum strength, a natural limit to its influence. Under this assumption, the orbital deviations in galaxies lose their enigmatic character. They no longer appear as anomalies, but as necessary consequences of a deeper order, as traces of a law that we are only just beginning to recognize. However, we have not yet touched the origin of this universal force, that invisible hand that shapes stars, binds galaxies, and ultimately created the conditions for our own existence. Perhaps this unanswered question is not a lack of knowledge, but an invitation to continue asking, to look further, and to rediscover our place in this vast, silent cosmos. So let's try to ask the right questions, dive deeper, and dream of the beginning of everything. The standard cosmological model states that in the early universe, almost equal amounts of matter and antimatter existed, but with a tiny excess of matter. After mutual annihilation, the small residue of matter remained, from which the present-day universe arose. But doesn't this assumption violate the first law of thermodynamics? To understand this question, we need to understand what this sentence actually means. The first law of thermodynamics is the law of conservation of energy. It describes a profound order in the changing nature of things. In the language of physics, it reads delta U equals Q minus W. The eternal energy U of a system changes when energy is supplied to it as heat, Q, or when it releases energy to its surroundings in the form of work, W. Every change is recorded. Every transformation has an origin. Energy can neither be created nor destroyed. It can change its form, from motion to heat, from matter to radiation, but its total amount remains unchanged. Shouldn't this physical law therefore apply everywhere? Let us dream then of a universe containing equal amounts of matter and antimatter. What would such a universe look like, and how would it behave? As the Casimir effect teaches us, the vacuum is not empty. Even in apparent nothingness, particles and antiparticles are constantly being created, only to annihilate each other in the same instant. But what if we simply wait? Wouldn't it be conceivable that a particle-antiparticle pair could be created, and during this fleeting moment, another pair could appear, positioned in such a way as to spatially separate the first? Couldn't such a process repeat itself again and again over unimaginably long periods of time? Gradually, larger quantities of matter and antimatter could be created in this way, until finally an entire universe emerges. We must not forget one thing. We have an infinite amount of time at our disposal, billions of years, perhaps far more, and yet, even that, measured against infinity, is scarcely more than a moment, a brief flicker of a universe and an anti-universe, a fleeting instant in the great stream of being. Just as the Casimir effect is merely a quiet, barely perceptible phenomenon for us, this interaction on a cosmic level could also appear silent and inconspicuous. Perhaps a universe and an anti-universe interact in a similar way, not on a small scale, but on unimaginably vast ones. And perhaps it is precisely this gentle, ubiquitous interaction that seems familiar to us, as the force we call gravity. Thank you for watching my video. Stay tuned and keep dreaming of the universe.